Alright, so it turns out that there is more than one way to write a quadratic. Standard form was one of the ways we learned how to write a quadratic, and standard form looked like this: y is equal to ax squared plus bx plus c, and we would do a lot of things to figure out what the vertex was and the y-intercept and all of that. However, there's another form that our quadratic could be in, and this is called vertex form. And the vertex form is right here. Y is equal to a times x minus h to the second power plus k. The h is going to be the x-coordinate of the vertex. The k is going to be the y-coordinate of the vertex. So the reason this form is called vertex form is because it gives you the x and y coordinates of the vertex. It does not require you to do anything to find the vertex. If the a value, the number out front, is positive, it will open up, so that's the same. The a value determines if it opens up or opens down. However, the h and k values determine the vertex, and it's a minimum if it opens up and a maximum if it opens down. The axis of symmetry is the h value. X is equal to h, so whatever that h value was, that's also the axis of symmetry. And then, since we don't have a c value, like in standard form, we find the y-intercept by substituting 0 for x. So we're plugging in 0 for x, and that will give us the y-intercept. And then we reflect the y-intercept to find the axis of symmetry. That part's the same. So let's see what one of these looks like in vertex form. Or first, let's look at a couple and identify the vertex and the axis of symmetry. Now remember, we're looking at this form. Y is equal to a x minus h squared plus k. Alright, you can tell that this is not, number one, this is not in standard form because there's no x squared, there's no x term. It's a binomial, x minus 4, parentheses, with an exponent on the outside. So this is in vertex form. There is an a value here, it's 1, but we're just looking for the axis of symmetry and the vertex. Now if you look up here, x minus h, and here we have x minus 4, and the vertex is h comma k. So 4 is the x-coordinate of the vertex because h is what's being subtracted here, and what's being subtracted is 4. So 4 is the x-coordinate of the vertex. Let me do that in a different color so we can see it. I'll do it on pink. Alright, 4 is the x-coordinate of the vertex, and then the y-coordinate of the vertex is what's being added on the end here, plus k, and the k is 2. So the vertex for number 1 would be 4 comma 2. And the axis of symmetry is just the h value, so x equals 4. Now if we look at number 9, this is, we have an a value, 1. So it's x plus 9 to the second power minus 3, so this is in vertex form. Alright, so when we're looking at the x minus h part, the h is what's being subtracted here, and this says plus 9. So we need to look at this as if something's being subtracted, and what's being subtracted here would be a negative 9, because in order to make this positive, we'd have to subtract a negative 9. Alright, so our x-coordinate of the vertex is negative 9, okay? Because in order to get plus 9, and we're subtracting the h, in order to get plus 9, we'd have to subtract negative 9, because x minus negative 9 is x plus 9. So negative 9 is the h value, and then the k value is what's being added on the end here, and that's a negative 3. So the k value is negative 3. So the vertex is negative 9, negative 3, which means that the axis symmetry is just this. X equals negative 9. All right. All right, so for number 3, for the h value, we are looking for what's being subtracted inside the parentheses, and we see that a 7 is being subtracted. So the x-coordinate is a 7. For the k value, we're looking for what's added on the end, and there's nothing added on the end here, so we can just put 0, because technically it'd be plus 0. The axis of symmetry is, of course, the h value, so it's x equals 7. So vertex form is very useful because it just gives you the vertex. And keep in mind, the x-coordinate of the vertex is going to be the opposite number that you see. So if you see minus 4, it's a positive 4. If you see plus 9, it's a negative 9. If you see minus 7, it's a positive 7. All right, so we want to graph this. So keep in mind the a value here is the number out front. If it's not written, put a 1 there so that you know what it is. So in this case, the a value is 1, the h value, and the k value. So the h value, remember, we're subtracting because it's y is equal to a x minus h squared plus k. So the h is being subtracted. So it's going to be the opposite of what we see here. So it's negative 1, and the k value is negative 5. So this opens up because the a value is positive. It's 1. The vertex is h comma k. So negative 1 comma negative 5. This and this. Since it opens up, that's going to make this a minimum. And the axis of symmetry is just this right here, x equals negative 1. All right, everything about this so far has been easier. The only thing that's a little bit harder, or it's not really that hard, is the y-intercept. And the y-intercept is pretty straightforward. We take the equation and we substitute 0 for x. So instead of x plus 1 squared, it's 0 plus 1 squared minus 5. And then we evaluate using PEMDAS. So 0 plus 1 is just 1. 1 squared is 1. So negative 4 is the y-intercept. The y-intercept is 0, negative 4. So this is actually a little bit easier than standard form, or it should be, because there's less math involved. So the y-intercept is 0, negative 4. We're going to graph everything the same way we would from the other form. We're going to do it in the exact same order. Axis of symmetry first, so that's at negative 1. After the axis of symmetry is the vertex, so negative 1, negative 5, that's right here. After the vertex is the y-intercept, so 0, negative 4, that's right here. And then we reflect that point onto the other side, so right here. And then we draw our graph. Something like this. Our domain, of course, negative infinity to infinity, that's still the same for every quadratic. The range, since this has a minimum, the minimum boundary is down here at negative 5, and it has no maximum boundary. So this is negative 5 to infinity. All right, so for this, we want to try 2 problems for the homework. This is day 1. We are going to be working on this tomorrow. Make sure you show your work for the y-intercept.